In today's lesson, we're going to start with the X and Y coordinates contained inside a spreadsheet, such as this Excel file, and use those to generate a curve inside SolidWorks, which then can be the basis for, say, an airfoil for a wing, or the turbocharger turbine, or even a vacuum cleaner. Let's get started. So we go and do a quick search for airfoil and database. We'll come up with the University of Illinois site at Urbana-Champaign, and this takes us to an airfoil coordinates database with 1,600 different airfoils on it. And you can just page down through this until you find the airfoil that you're interested in. For instance, I'm going to come down here to Rutan Amsoil Racer Wing Airfoil. Bert Rutan always has some interesting things. So I'm going to download the Amsoil 2 data file. And I'll go into my download folder and pick the Amsoil data and bring it into Excel. Now, this is a text file that we're going to convert into Excel file, and it's a delimited file, which is what we want. If you're on fixed width, go ahead and click on delimited, and then this is a space delimited file, so I need to also click space down here, and that will correctly order the file in columns. And it comes in as basically an X and a Y coordinate for this wing, this airfoil shape. Now, it needs a little bit of cleanup here. So first thing we need to do is wipe out anything that's not coordinates. So I'm deleting those rows. I'm going to delete this column. And one other thing is that SolidWorks only takes XYZ files. I'm going to add a Z column. So I put Z in my third column over, grab it, and pull down to fill down the page until I've got all my Z's are also at Z0. Now, of course, you could put them at any Z, but Z0 puts it on the plane that you're working on. Now, there's a few other issues here. This data starts off at 0, 0, and then starts to grow in the X and Y coordinates here until it comes to this point where it comes to X is 1, Y is 2 thousandths essentially, and Z is 0. This column will cause us, or row will cause us problems. And then the data jumps to the bottom of the airfoil. So it drew the top of the airfoil, now it's drawing the bottom of the airfoil, and that's going to confuse SolidWorks a little bit because it will see that as a self-intersecting curve and won't draw it. So we need to manipulate this information just a little bit here. So what I'm going to do is grab the bottom half of the wing. I'll select it and place it over here. Now, you could bring these in as two separate files, and that would work just fine too. But if you're handy in Excel, you can do it this way, which is, if we look over here at my first one, the X is growing up to 1, while the Y decreases a little bit. I'd like to start at that point and work my way back to 0. So I need to invert this second set of data here. So I'm going to highlight it, and I'm going to come over to sort and filter, and I'm going to sort largest to smallest, and it's going by column E here. And now I'm starting at 1 and working my way back down to 0, 0. So at that point, I'll grab the information cut it again, put it over here, and paste it. And the only thing I need to do next is remove this, and I might even fudge some data in here to give it a point to go to 1, 0. You see, it has a very almost symmetric wing here. Not exactly, but almost. And now I can save this data, and I'm in pretty good shape. So I'm going to save as. Now there's some tricks here too. I'm going to save it to my desktop. It wants to save it as a tab delimited, and that's, I believe, will work out okay. Ru10, and I did modify it slightly. So I'll save it as Ru10 modified. And I'm going to put a TXT extension on the back of this file because that seems to help it sometimes. And save. And it's going to have problems with this. The other trick that I've learned is that you have to close this file right now, or SolidWorks will have difficulties opening it. So I'm going to close it and go to SolidWorks. Now the interesting thing about inserting a curve inside SolidWorks from an XYZ file is that this is not done on a sketch. So I have nothing out here. So what I am going to do, and I don't have any sketches open, so that will actually goof you up if you do have a sketch open. So we go to Insert, and then come down to Curve, and you can see it says Curve through XYZ points. I'm going to go Browse, and the default setting that it's looking for is a curve file, a SolidWorks curve file. So that's a file that can be generated from SolidWorks, but in this case we're looking for a text file. And here's my Ru10 modified file that I'll open, and it puts all your data into your XYZ columns here in your curve file, and if everything's going right, gives you a little preview of what you should see out here. At this point I'll hit OK, and hopefully I get no error messages. And I have my airfoil that I can start to do things with. So, such as extrude it. Extrude boss base. Select a plane from which to sketch. Let's go from the front plane. And there's nothing on the front plane to extrude. It looks like this curve is on there, but it's not. If I go in and hide this curve, you can see there's nothing there. So if I get in the curve and show the curve, one of my favorite buttons in SolidWorks is Convert Entities. Sketch 1 is open. It's hot. I can tell it because over in this corner I have my icons in the corner. I will hit Convert Entities, and now there is a curve on Sketch 1 that I can actually go in and extrude. And I have the Amsoil Racer airfoil here available to manipulate. Now if you wanted to scale it, there's a couple of ways you could scale this, because currently it's only 1 inch long. That's pretty tiny. So insert features, let's try a scale feature. Scale about the centroid, uniform scaling. Yeah, I'd like this, say, 5 times larger. And of course I can edit that. I could scale around the centroid, around its origin, so that takes it from the origin and stretches it to the sides. Or from some coordinate system, but you have to predefine your coordinate systems to get that to work here. So if you uncheck uniform scaling, you can scale this in different amounts in different axes. I'm not sure why you would in this case, because Bert Rutan has done a lot of work to get his airfoil how he wants it, and I don't know if he'd appreciate you messing with it. I think you could, just don't call it a Rutan anymore. There is another way to scale these. Inside Excel, you've got your original data. If you wanted to scale it by 5 times the amount, fill to the right, then fill down, and the result is a wing that is 5 times larger than the original. So here where it went to 1, we now have 5s. You could import this XYZ file. Of course, you'd have to highlight your data, cut it, and save it to its own file and bring it in from there. But that gives you an idea of how to bring in parts, bring in Excel files as curves into SolidWorks. Incidentally, this is also the way you would graph a curve inside SolidWorks if you needed to show it for, say, a math class or something, and had some data that you wanted to show. Just open a new drawing and go to Insert a Curve through XYZ points. And don't forget that you don't have any sketches open. And to get your data into these points, double click on the cell. We'll do one at 0, 0. Our second point will be 1 over, 1 up. Next point will be 2 over, 4 up, 3 over, 9 up. We'll switch this to front view so we can see it a little bit better. 4 over, up 16. And before you click OK, you may want to save this data, because otherwise it's going to lose it, actually. So we'll do Save As, and it's going to save it as a curve file now. So I'll just save this as parabola number 1 solid curve. And it puts that curve on my screen, which then if I go to front plane and open a sketch on that plane and go to View and Grid, I can kind of convince myself that this is going through those points 0, 0, 1, 1, 2, 4, and so on. So I can actually use this, I can actually use SolidWorks to graph my math problems. Now this is not a smooth flowing curve. It's going through those points, but it's not a nice smooth spline through those. If I want to spline through those, I need to go to my front plane, open my sketch, and put in points, and tell it these coordinates. Delete any existing relationships and tell it the coordinates you want it to be. I'll do this just to avoid any entanglements. Alright, if I add a spline to these from 0, 0, 1, 1, 2, 2, 3, 3, or excuse me, 2, 4, 3, 9, and 4, 16. If we compare these two lines, you can see that there is some discrepancy between them. Now, if we happen to know the equation that we're trying to get here, we can go to Tools, Sketch Entities, and go to an equation-driven curve. Equation that I'm looking at is x squared. X is between 0 and 4. And it's going to draw in an actual accurate sketch of my parabola, which is slightly smoother than my spline. It's a bit smoother than my spline and actually much more accurate down in this area between 0 and 1.